Water, it's everywhere we look. It falls from the sky as rain. It flows in rivers and oceans. It even exists as ice and snow. Water is essential for life as we know it. But have you ever stopped to consider what makes water so special? We find water in all three states on Earth: solid, liquid, and gas. This is unique. No other substance on our planet naturally exists in all these forms. This cosmic dance of water is a testament to its remarkable properties. Imagine the surface of Mars. It's a dry, desolate landscape, but scientists have discovered evidence of water there. This finding ignited our imagination. Could life have existed on Mars? The search for water beyond Earth underscores its importance. Water is not just a substance, it's a fundamental ingredient for life. It's a key to unlocking the mysteries of our universe. Why is water so crucial for life? Think about what makes up a living organism. Cells, tissues, organs, they are all primarily composed of water. Water acts as a solvent, transporting nutrients and removing waste. It's the lifeblood of every living thing. From the smallest bacteria to the largest whale, every organism depends on water. Plants need it for photosynthesis, animals need it for hydration and bodily functions. Water is the common thread that connects all life on Earth. Without water, life as we know it wouldn't exist. Our planet would be a barren wasteland. It's no wonder that ancient civilizations revered water as a sacred element. The next time you take a sip of water, remember that you're not just quenching your thirst. You're participating in a cycle that has sustained life for billions of years. The secret to water's incredible properties lies in its molecular structure. Picture a water molecule shaped like a V. At the bottom of the V is an oxygen atom. At the tips of the V are two hydrogen atoms. This simple arrangement holds the key to water's power. The oxygen atom has a slight negative charge. The hydrogen atoms have a slight positive charge. This makes water a polar molecule. It's like a tiny magnet with a positive end and a negative end. This polarity might seem insignificant, but it's what gives water its unique properties. It's what allows water molecules to interact with each other and with other substances in fascinating ways. Let's dive deeper into the world of water molecules and explore how this simple polarity creates a symphony of wonders. The slight charges on water molecules create weak attractions between them. These attractions are called hydrogen bonds. Don't let the word weak fool you. While individual hydrogen bonds are fleeting, collectively they are incredibly strong. Imagine a group of people holding hands. Each individual grip might be easy to break. But if the group is large enough, it becomes incredibly difficult to separate them. Similarly, countless hydrogen bonds give water its remarkable properties. These bonds are responsible for water's high boiling point. They also play a crucial role in its ability to dissolve substances, making it an excellent solvent. Hydrogen bonds are the invisible glue that holds the world of water together. Without hydrogen bonds, water would be a gas at room temperature. Life as we know it wouldn't exist. These tiny bonds are the unsung heroes of the water molecule. Section 5. Cohesion and adhesion. Water's teamwork. Have you ever seen a water strider effortlessly gliding across a pond? This remarkable feat is possible because of water's cohesion. Cohesion is the attraction between water molecules. It's like they're holding hands, creating surface tension. Adhesion is another fascinating property of water. It's the attraction between water molecules and other substances. For example, water adheres to glass, which is why you see water droplets clinging to your window on a rainy day. Cohesion and adhesion work together in many natural phenomena. They allow plants to draw water up their roots against the force of gravity. They also help blood circulate throughout our bodies. These properties might seem like simple physics, but they are essential for life on Earth. They are a testament to water's incredible ability to connect and interact with its surroundings. Section 6. Capillary action. Water's gravity-defying feat. Have you ever wondered how trees transport water from their roots to their leaves, defying gravity? The answer lies in capillary action. This fascinating phenomenon is a direct result of water's cohesive and adhesive properties. Imagine a narrow straw dipped in a glass of water. You'll notice that the water level inside the straw is slightly higher than the water level outside. This is capillary action in action. The water molecules stick to the sides of the straw through adhesion. At the same time, they stick to each other through cohesion. This combined force pulls the water column upwards, even against the force of gravity. Capillary action is crucial for plants. It allows them to transport water and nutrients from the soil to their leaves. It's another example of how water's unique properties make life on Earth possible. Section 7. The universal solvent, water's dissolving power. Water is often called the universal solvent because it can dissolve more substances than any other liquid. This unique ability makes it incredibly important in both natural and human-made processes. This property is essential for life. Without water's dissolving power, many of the biochemical reactions necessary for life wouldn't occur. It allows water to transport nutrients, minerals, and other essential substances within living organisms. This transportation is vital for the growth and maintenance of all living things. Think about adding sugar to your coffee or tea. The sugar dissolves in the water, creating a sweet solution. The sugar dissolves in the water, creating a sweet solution. This everyday example highlights water's ability to break down substances and distribute them evenly. This happens because the polar water molecules surround the sugar molecules, breaking them apart and distributing them evenly throughout the liquid. This process is known as solvation. However, not everything dissolves in water. Some substances, like oils and fats, do not mix well with water. Oil, for example, is hydrophobic, meaning it repels water. This is why oil and water don't mix. The molecular structure of oil prevents it from interacting with water molecules. Water's ability to dissolve some substances while repelling others plays a crucial role in biological processes. It helps maintain the delicate balance necessary for life. From transporting nutrients in plants to carrying oxygen in our blood, water's role as a solvent is fundamental to life as we know it. It's a chemical magician, constantly at work dissolving and transporting substances within and around us. This incredible property of water is what makes it indispensable in both nature and industry. Section 8. The density anomaly, why ice floats. One of water's most peculiar properties is its density anomaly. This unique characteristic sets water apart from almost every other substance on Earth. Unlike most substances, water is densest at 4 degrees Celsius, which is 39.2 degrees Fahrenheit. At this temperature, water molecules are packed most tightly together. This means that ice, the solid form of water, is less dense than liquid water. As a result, ice floats on the surface of water rather than sinking. This might seem like a trivial fact, but it has significant consequences for the natural world. But it has profound implications for aquatic life. The floating ice acts as a barrier, protecting the water below from the freezing temperatures above. When water freezes, it expands and floats on top of the liquid water below. This expansion is due to the hydrogen bonds in water molecules. This creates an insulating layer that protects aquatic life from freezing temperatures. Without this layer, many aquatic organisms would not survive the winter. Imagine a lake in winter. The surface is frozen solid, creating a thick layer of ice. However, beneath this icy surface, the water remains in a liquid state. But beneath the ice, life continues to thrive in the liquid water below. Fish and other aquatic creatures can continue their lives despite the freezing temperatures above. This is only possible because of water's unique density anomaly. This property ensures that ice floats, providing a crucial survival mechanism for aquatic life. If ice sank, lakes and oceans would freeze from the bottom up. This would drastically alter the ecosystems within these bodies of water. Aquatic life would be trapped and eventually perish. The entire balance of aquatic ecosystems would be disrupted. Water's unusual behavior ensures that life can persist even in the harshest of winters. This remarkable property of water is essential for the survival of many species. Section 9. Water's thermal shield, protecting our planet and ourselves. Water has an incredibly high heat capacity, which is a unique and vital property. This means it can absorb a lot of heat without a significant change in temperature, making it an excellent thermal buffer. This property is crucial for regulating Earth's climate and maintaining stable temperatures within living organisms, ensuring a balanced ecosystem. Oceans act as massive heat sinks, absorbing heat from the sun and distributing it around the globe through ocean currents, which play a key role in climate regulation. This helps to moderate temperatures and prevent extreme climate fluctuations, creating a more habitable environment for all life forms. Water's high heat capacity also plays a vital role in our bodies, helping to maintain our internal temperature. It helps to regulate our body temperature through sweating, a natural cooling mechanism. When we get hot, our bodies release sweat, which evaporates and cools us down, preventing overheating. Without water's thermal buffering capacity, Earth would be a planet of extremes, with temperatures swinging wildly. Scorching deserts would dominate the landscape, and life would struggle to survive in such harsh conditions. Water's ability to moderate temperature is a testament to its role as a silent guardian of our planet, ensuring a stable environment. Water is more than just a molecule, it's a fundamental component of life on Earth. It's a life giver, a climate regulator, and a source of endless fascination, playing multiple roles in our ecosystem. From its unique molecular structure to its remarkable properties, water continues to surprise and inspire us with its versatility. So, the next time you encounter water in any of its forms, take a moment to appreciate its magic and the vital role it plays in sustaining life on our planet.